Okay, good morning, class. As usual, let me see if there are questions for a couple of minutes before we start. So this week we started the first lab in Java. I hope you started doing the lab. Hopefully the environment is going okay. How do we get to the system properties window that you showed in the tutorial? So Elizabeth, I just copied. So you can get it using two different ways. Either open the control panel if you are using Windows, or you just type in the search, let me remember, advanced system properties or something like this, the thing that I have done in the video. Yan, how are you going to post the video for install Eclipse for Java? Yan, how I already posted the video for the tutorial, which includes what you need to do for the environment. Jumbo, what is the link for Java Online Compiler? I guess you already emailed me about this. The one that I have been using is Rebel, like rebl.com/Java. But I just recently discovered today that they might require you to sign up. I guess they changed their business model, like some features now became like you have to sign up. I'm not sure if even it requires a payment. So today I'm going to try also online GDB and let's see if it works. But any online compiler would work, right? Moaz, do we know when midterm mark change will be on Avenue? Hopefully by this week. I just want to find like 1 hour or so to update everything and re-upload it. So hopefully by this week everything should be updated. Yes, the slides are posted. When will you post the video for the last lecture? Everything is already posted on the YouTube channel, or including the last lecture. Any updates on Lab 2 marks? They are going to be out today. Salah, when you download the Java package, is the Eclipse exe the same as the one we had before? No, it's a different one. Like this Eclipse exe is the one that you need to use for Java because it includes the Java packages. So it's not the same as you had before. I sent an email about my midterm feedback and still haven't heard back over a week. Should I just resend it? I would appreciate this, Katie. Yes, please. If I didn't respond to you, I apologize for this, but please resend it and let me see. How can we push our code if there are no terminal on our Java Eclipse? There should be a okay. That's also another thing. So you really can have the terminal similar to what you have in the Eclipse for C. If you don't have it by default, simply install it exactly the same way we installed it in Lab 0. So I guess if I remember, you go to Help and then the Eclipse Marketplace and then type terminal and then just install and it gets installed for you. We already have these steps, I guess, in Lab 0. It's exactly the same step that you need to follow. But it's the same name and I can't launch it. Gives no, you don't need to delete anything. Yes, it's the same name, that's fine. I already have the Eclipse for C in my machine and I was able to run it fine. So you shouldn't have any problem. Okay, good. So yeah, so let's start. So this lecture we are continuing what we started with discussing classes and object-oriented programming for Java. So again, the main purpose of why we are covering Java is we want to convey to you or educate you about the object-oriented programming concepts. So make sure you focus on these. What is the concept rather than how you type things? Because if you know the concept for OOB, you can really apply this to any other language. But if you only focus on the syntax and see things how like they work, you really lose much of the knowledge I want to convey to you, right? Good. So last time and the time before we started classes, we have seen how to declare a class, declare objects of this class, create an instance in the main, and test it, also write methods and define instance variables. And last time we also discussed, in addition to the instance variables or the normal variables, the ones that we know, static variables as well as static methods. This is what we covered so far. So now we kind of compound on this as well. So we have more examples. We are going to write more methods and see how we can use them. We are also going to add definitions. So again, the mentality here is once you define a class, you can really use it as your own defined type, which means previously we were able to define arrays out of different types, like arrays of doubles, arrays of ints. So today we also will see how to define arrays of classes. And you guys have already done this partially by structures in C in lab 3 as well, and in our last lecture in C. So it's the same terminology, but instead of structures in C, we are going to do this for classes in Java. Good. So let's revisit some of the concepts behind OOP. In procedural programming, what do you mean by procedural programming? So this is a terminology used for programming languages that don't support object-oriented programming. So everything is run sequentially, starting from the main. If you have a function call, as we discussed before, you go to the function, execute it. Once you return, you go back to the main. So everything is procedural or sequential, right? And the main theme of procedural programming languages is variables and actions. Those variables or the data is really the types you define, and actions are the functions. Both are separate. And if you want functions to operate on data, you just pass these as input parameters, right? On the other hand, for OOP or object-oriented programming, data and actions can really be encapsulated or combined into what we call objects. And we have seen in previous lectures, one object can include its own characteristics as variables, as well as its actions as methods, right? And the main theme or mentality behind OOP is objects can really model real objects in real life, right? And we will see some examples about this right now, some funny examples that people usually do, but any object that you can think of reality, really the straightforward way of thinking about real objects or use cases is to think about objects in object-oriented programming. Good. And the main thing is by defining a class, you really is defining like a template or a blueprint for objects of the same kind that have the same characteristics. Good. And we have discussed the advantages of OOP before: encapsulation, reusability, integrability, extensibility as well, having different versions, security, all the things we have been discussing last lectures and the lecture before for setters and getters. Good. So let's have one example. If you have a dog, if you have a dog or a pet, you can think of this as an object, and by looking into an object, so this is how you think of object-oriented programming in general. So first of all, model your object or class as something in real life. Here in this example, it's dog. And then you need to think of two things for this object. The first thing is, what are the attributes, the characteristics, the features, right? For example, for the dog, what is the weight of the dog, the fur color, maybe the name, like eye color, different things, right? So these are the attributes of the dog. Good. Which means the features that every dog has different than like other dogs. And also, so the first thing is features or attributes. The second thing is behavior or actions, right? So think of different actions for a dog or any pet. That a dog can run, eat, bark, sleep, play, do different things, right? So those actions, now we thought of a real object in real life with features and actions. Good, this is the first step. The second step is modeling this into object-oriented programming. So what we do is actions are modeled as methods, and features are modeled as instance variables, or let's say in general variables. Right, this is why we said any class consists of variables and methods, because a class models something in real life which has features and actions. Thinking of the lab, for example, you are creating this student list. So I guess you have done this in lab 3. Let me try to remember what you do in lab 4. The matrix class, right? But let's even talk about lab 3 for structures, like the student database of a course, the one that we were discussing before. Now your object is the student. This student has, again, attributes, characteristics like date of birth, ID, numerical ID, user ID, first name, last name, right? And then the actions of a student can enroll in a class, can withdraw a class, and student goes through exams, have average marks, and then also you can calculate the total grade or mark of the student, right? So those are the actions and the features. So for if you want an exercise for classes in Java, you can really do lab 3, which is using structures in and dynamic memory allocation in C, but do it using classes in Java, right? This is a direct application of that can show you the difference between Java OOB and structures in C. Good. So let me see if there are questions. When I call a method that is not static from the main, which is static, it gives me a compilation error. So Nicole, I'm not sure if I get your question, but here is the rule. Regardless of whether this is static or not, as you said, static has nothing to do with scope, but you need to see whether your method is public or not. If it's private, you cannot call it from another class. Let's assume it's public. So you need to use the object name dot. You cannot just use the function name, right? And we will have more examples about this today as well, right? So I hope this will answer your question. If not, please ask when the time comes. Good. So this is kind of the mentality that I want to convey to you, how to think about a real use case and transform it or resemble it in object-oriented program. Good. And following the same terminology, invoking an instance method in object-oriented programming is simply asking your object to perform a certain action, right? So for example, if you have an object called Rex of the class dog, so now we define the template, which is the dog class, right? This is the class. Then you can instantiate different objects. One of them, if everyone has his own or her own dog, for example, then let's say we have an object Rex, we call this an object, and then invoking a certain method, you are asking your dog to do something, right? So this is, again, the terminology we are following here. Good. We also discussed the difference between static fields and methods and instance fields. Simply instance variables or variables in general, if they are not static, they have different values per objects, right? Last time we have discussed the point class, and we are going to revisit this lecture. And we have the XY points, which every object has its own X and Y. On the other hand, if you remember, we defined the count static variable, and this count has the same value for everyone because it's really not associated to a certain object. A static variable is associated to the class itself, right? So the value of a static field doesn't depend on any particular object. Again, it's the same for all objects, and every object is able to see its value, right? We have seen all of this last lectures. For example, here, following our terminology, if you say, for example, all dogs have 4 legs, then it might be a good behavior or modeling if you model the number of legs for a dog to be a static field, because all objects will have the same value, right? Good. Okay, so good. So now let's revisit our point class, the one that we had from last time. Again, we had 2 instance fields, the points, like the Cartesian points or coordinates X and Y. We also had a static variable count that counts how many objects are created. And we have the constructor that takes as an input 2 input parameters and sets the values of X and Y accordingly. And we said also we want to increase our count when the constructor is being called, because we want this to be independent of the object or the user behavior. Every time you create an object in the main, for example, we are going to increase the count by default. Good. And then the setter method and the gets, right? And then again, the get for the count. All of this we have done last time. Good. So now let's build on top of this. But I guess there are things going on in the chat. So let me see. Question, Yan Hao. Does different instance has different scope of static?
I guess you have answered that question on the slide.
Okay, thank you, Yan Hao. Yeah, thanks. So would I need to create an object of non-static method Yes, if it's a non-static method, you cannot refer to it, Nicole, without an object, right? So in instance methods or in instance variables, both are characteristics or both are members of objects. That's why you cannot call them without an object, right? And we will see this again today. Good. So let's build on top of our point class. We assume we want to add another method, and this method, what it does is going to scale our x and y, right? For example, assume you were operating on a certain, I would say, resolution of x and y, and then you want to increase your resolution, so you are going to scale x and y accordingly. We want to write such method, right? So simply take a value and then multiply x and y by this scaling factor. Good. So from last time, we also, this is an application of how to use this. Given that scale is an instance method of the class point, so really it doesn't need a class or an x and y passed into it as input parameter. It can operate on x and y by default, right? Because both are members of the same class. And then it doesn't need to return anything because it can update x and y accordingly, right? The only thing we need is simply to pass the scaling factor, right? So what we want to do is pass a scaling factor, and then according to the scaling factor, we're updating x and y. One question to you here is why I just wrote x and y directly, and can I use a different way of doing this? So why I'm able to access x and y? These x and y are not passed as input parameters. So why I'm able to access them directly and update them? This is one question. Global variable, yes, but we had a different terminology, Nicole. They have the same effect as you said, but they are not global variables. They are more of instance variables of, instance variables of this class, right? So you are able to access them. That's good. And then the second question is, can we write them in a different way? Instead of writing this, can I write these two lines in a different way? What do you think? This.x. Sitters Arjun, we will come into this, but you're generally correct. But what I meant is exactly this mark, like this.x. We can refer to x here as also this.x, right? From what we discussed last time, because this is simply referring to the current object and x is this member of this object, right? Here, so another question, which might be good to build on top of this, why here I was able to remove this safely, right? Because last time we discussed cases where really you cannot do this. So can someone answer why I was able to, why x or this.x are equivalent, for example? And it's safe to just write x in this method. No local variable in the method called the x mark. Excellent, thank you. So the thing is, we said you need, really this is mandatory if inside this method, you have another local variable that is called x. In this case, you need to differentiate between the member or the instance variable x and the local variable x. But here, because scale doesn't have any local variable that is called x, referring to x is simply, we only have one x, which is this one, right? This is why using this.x or just x directly is the same thing. Good. So this scale method is just a straightforward one. What we have done is taking the scaling factor, multiply x and y by this value, right? Then I guess this is all discussing what we're discussing right now. Yeah. So the other thing is just to emphasize is here, this instance method didn't need to pass any point object or class into it. Why? Because it's operating on the current members of the object, right? There is another example, and I will show you from the lab right now the difference between both methods. So the first one, what we wrote here, which is equivalent to the set as well, it only operates on this members. So you really don't need to pass any object to it, right? While assume I want to write another method that calculates the distance between, so now I have 2 points. Remember what is our point class is resembling. Assume you have this plane and then you create different objects with different points, right? This is x1, y1. Let's say this is x2, y2. And now I want to write a method that calculates the distance between both, right? So why this method is different than the previous method? This method is different because here you need 2x and 2y, right? So simply you need to operate, excuse me. So you need to operate in two different objects, right? Previously in the scale, I was operating only on a single object, which is my current object or the this, right? While in the distance too, I need two objects because calculating the distance between 2 points requires two objects. One of them can be simply this, right? The one that I'm in right now. But the other one, I mean, I have already used this. So one question to you is really, how can I operate on the second one? What do you think we can do for the distance method to operate on two objects? I already gave you half of the answer, which is one of the objects can be this. What about the second one? What can we do? Pass it as an argument, you land a perfect mark, the same thing, yeah, pass it in, Nicole, that's correct. So that's completely correct. So I can use this as one of the objects and then pass the other object as input argument to this method, right? Good. And this is exactly what we are going to do. And then only one of the two limits, okay. And the other, maybe the other question to you is what this function needs to return, right? So now I'm passing the other object, I'm calling it that, just, this can be any name, right? That is not a reserved word, but we are calling it that to differentiate it from this, right? But it can be anything, good? And then the distance 2 is the name of the method. I'm passing that as an input, the other one is going to be this. Once I calculate the distance, I need to return it back, right? This is why this function returns double, right? Simply, good. And then all of this already covered. So if we want to write this, simply going back to the practical use case, if I have x1, y1, x2, y2, if I want to calculate the distance simply from math, I know that the distance is x1 minus x2, I guess that can be whatever is bigger, square, plus y1 minus y2 square, right? This is simply the distance between any 2 points in the Cartesian coordinates, right? Good. So so this is just this line, right? So math power, I will explain this, but it's just recalling the power function from Java, and then it subtracts like x minus x and that dot x, and we are going to visit this right now, but simply x1 minus x2 in our example, and then power of 2, which is taking the power of 2 here, and then again adding this to the power of 2, and then it remains to take the square root, right? So simply I then return math to the square root of g. Good. So this is the math behind this equation. Now let's revisit some of the OOP things that we want to discuss, right? And the main purpose of this example here. So let's see. First of all, x, y. As we discussed previously, what is this x, what is this y? What do you think? I will come into your question, Arjun, but what about what is this x, what is this y? This dot x, this dot y, exactly, in instance variables. So similar to what we discussed in the scale method, x and y are simply my current instance variables of the this, right? I can also write this dot x, but it's not needed, right? On the other hand, that dot x and that dot y, that is the class that I'm pointing here, and I'm referring to its member x and its member y, right? I can write it again, this dot x minus that dot x, that's also okay. And then to answer Arjun's question, again, that is not a reserved word. For example, I can call this class my class, this object, my object. I can call it anything, it doesn't really matter. And then I have to write my object.x and my object.y, right? So this is simply a variable name that you can call it anything. Good. And then at the end, I'm returning the square root of this distance. Any question here? Why can you use that x if x and y? Perfect mark. That's one of the reasons why really we have this thing. So Mark's question is the following. So I know that X and Y are private variables. And I told you last lecture, really you cannot refer to private instance variables or private variables outside the class. So simply you cannot do this in the main. And last lecture, we have done the exercise of trying to access a private member in the main, and it gave us an error, right? So now, Mark's question is, why I'm able to do this right now, or even if this is correct, right? The point is, distance to is a member method of the class point, right? Which means you can do this inside the class methods itself, right? So this is a difference between referring to X and Y inside a method of a class or outside the class, right? So if you want to visualize it to understand it, again, our point class is the black box. Distance to is a method inside this point class. What we have done last time is in testing point inside the main, for example, if you want to refer to X and Y here, you will get an error because that's a private variable. While distance to, given that it's a member of the class point, anywhere here, you can refer to X and Y, or even other objects, like not necessarily the this X and Y, but also any X and Y of any object, right? Moaz, this is exactly the same question as Mark, right? You really don't need this. You can write dot get xy if you want, dot get x instead of x, but simply if you are implementing a method inside the class itself, it's not needed, right? This is the main point here. Sagnan, can you explain again? Okay, can you? Okay, so Sagnan is saying, can you explain how to refer to an instance variable and a local variable with the same name in the same method? So the only thing you can do is you have to say this, right? Assume I have a method that I call scale. Let's go back to our scale function here. And I assume inside this scale, I define int x and y. Good. So, and then say x x equal x multiplied by a, but really you didn't initialize x. So something you can do is you say x equal this dot x, then y equal this dot y. So by just writing x or y, you are referring to these two defined local variables. If you want to refer to the instance variables, you have to use this in this case. Good. Katie, can you access distance to outside of the class because it's public? Yeah, the distance. Okay, yeah, that's correct. So we will see right now we are going to use it outside in the main. So given that the distance to method is public, as Katie is saying, I can really access it outside of the point class, similar to the set or get. That's correct. And we are going to have an example right now about this. Arjun, if you were passing an object of a different type than point, you would be forced to use getters. Correct, Arjun. That's correct. Yeah. So the rule is referring to private members of the same class is allowed because you are within the same boundary. Referring to private members of another class is not allowed, right? You have to think of the scope, right? Good. Okay, perfect. So we have went through all of that. So one thing to mention before we move forward is using the math library functions, right? In C, we had to include the math.h, and even some of you needed some compiler input parameters as well. But in Java, all the math functions are in the package java.lang, and java.lang is automatically imported by default. So you really don't need to import anything to use the math methods, right? Like the power, square root, everything else is simply just directly accessible because java.lang package is included by default for any Java program. Good. And I guess this is explaining the point that we were making, which is given that distance to is a member method, you can directly access the private fields or private instance variables of that class. Good. So now, assume we want to do the following. We want to create an array of objects of the point, right? So I want to create in the memory an array of different points, and then what I want to build on top of this is to calculate the minimum distance between every point and the origin. For example, in our I would say small use case for a plane, you would be creating different point objects over the journey of the flight, and then assume this is going to be done using an array of objects, and then I want to calculate the minimum distance between any of the points and my origin, 0 and 0, right? So this is what we want to write. Let me jump into an online compiler to show you this in practice. Java compiler. Okay, good. So here, let's hope that just online GDB works as expected. So what we have here is the point to Java class. I have it in, again, like a file named with the same as the class name, and it has all the methods except the distance to. So let's write the distance to method. So let me just save time, copy and paste it. Distance to. Okay, here. I guess you guys are able to see online GDB, right? If not, please let me know. Okay, good. So now what I want to write here is the distance to method, which is this one, like the one that we just wrote. Good. And then what I want to do, this main exercise, is to create an array of objects of the class point, and then, as I said, calculate the minimum distance, or not the minimum, like the object with the minimum distance to the origin, right? So how to do this? First of all, let's create the class of objects, the array of objects. How to create an array? Simply you write the name, the type, not the name, the type of the array, and then the array name, let's call it, I don't know, points array, something, anything. And then equal, I have to either do this or this, and then equal new point, right? And then let's say I initialize everything to 0 and 0. Good. So any questions so far? So this is exactly how we but before this, let's really define how many points I want. Let's say I need 10 points. So here, the main trick and why we want to discuss arrays of objects especially, and I want to show it in practice, is if you remember from creating arrays in Java, we needed to do two things, right? As we discussed in the arrays lecture, the first thing is declaring the array. And by declaring it, simply just doing this, it doesn't give you any allocated memory yet. And then you have to allocate the memory, right? The problem here is that the example is really compound. Like you want to create two different memories, right? The first one is allocating the memory of the array, which what we have done right now. But the main trick is yet we didn't create any memory for the objects, right? So there are two memory types you need to create. The first one is for the array. The second one is for the objects, right? So far, what you created by this line is an array of points that has 10 locations, right? But until now, you didn't really create any point object, right? You just declared them. Good. Then I need to go through all these points one by one, and I equals 0. And I less than or equal to 10, and then I plus plus. And then I want now to create the object. So what I can do is to say, let's say point I is one entry in the array. I'm going to visualize it right now in the PowerPoint. Is one entry in the array, which resembling an object, right? So you yet need to create the object itself by saying new point, and here you need to pass x and y, right? By passing x and y, I can really pass anything. Let me say I want to pass, I would say maybe I and I, anything, right? Any initial value. So what is the difference between this line and this line? Again, here we allocated the memory of the array. While here, what we have done is we allocated the memory of object point. Oh, I'm just doing it wrong. This should be points array, right? You guys should. This is the array name, right? Create the objects of points array I, right? So this is why if you want to create an array of objects, you need to do it in 2 steps. First of all, declare your array and allocate its memory for different entries, here 10 entries, and then create the objects one by one. Good? Any question here so far? Yeah, this is going to give you 11 elements. Yeah, that's correct. Less than, yeah. Shouldn't, yeah, that's correct, yeah. Okay, good. So this thing is the main trick here, right? Then afterwards, by declaring these and like assigning initial values of x and y, let's go to calculating the minimum distance to the origin, right? First of all, how can I define the origin? What you want to do is, but let's say I want to simply here we know the origin because 0 and 0 is really the first one, which is going to be the origin. Can you explain why you put 10 in the second square bracket? Because this is how many array elements you want, right? So in declaring an array and allocating the memory objects, you say how many objects, sorry, not many objects, forget about objects right now. So let's say I want to create an array of doubles. So what I can write is double my array, then equal new double, and then 10, right? This is how we create an array of 10 elements of double. If we go back to the arrays lecture, right? Here is exactly the same thing, except that instead of the built-in type of double, we use our defined type, which is the point class, right? Good. So the first line is just like point array calloc. Yeah, now don't think of calloc thing. Yeah, you are correct in the sense that you first define the array of addressees and then define the actual arrays, but it's the same mentality. That's correct, right? Arjun, you are doing assignment and allocation at the same time in this example, right? But we can all, that's correct, Arjun, that's correct. How do you do dynamic memory allocation in Java? There is no, there is no dynamic memory allocation in Java. And that's one of the main differences that we discussed for the first lecture in Java between C and Java, right? Like we said, the mentality here is there is no dynamic memory allocation. You don't have fine-grained control on the memory. You only define references and objects, right? And memory get allocated by default for you. Perfect. So now let's proceed with the example. So assume I want to calculate the minimum distance to the origin. So what I can write is, first of all, what is origin? What you want to do is create another class. Let's call it origin object. I can call it anything, just origin, that's also fine. And then equal new point, and my origin should be 0 and 0, right? And then I need simply, so let me ask you, what would be the logic or the algorithm that I can do to calculate the minimum distance or to determine the array index that has the minimum distance to the origin? What do you think? How should I approach this? Now I have 10 elements. I have my point 0 and 0, which is the origin of the coordinates, and I want to calculate the minimum. For loop, this exactly, Sarah, that's correct. I am going to do a for loop over all, use the distance method. Nico, that's also correct. So what I can do is go through all the elements of the array, which are objects of point, one by one, calculate the distance to the origin, and then keep track of the minimum one. So what you guys said is correct, but you are missing one important step, which is over those 10 elements, I want to keep track of the minimum one. So how to keep track of the minimum one? Here I'm going to define, because distance is generally double, I'm going to say maybe minimum distance and also distance. Let's say minimum distance is like this, equal 0, and distance equal 0. Good. And then I'm going to do another for loop over all the elements. Maybe, okay, so the good thing is I can assign my minimum distance to the first element to say min distance equal, and then points array of 0 dot distance 2, and then I should pass the origin object. And then now I assign my minimum distance to be the first one, right? Later I'm going to update this, but just to initialize minimum distance, right? And then going over all the elements one by one, I want to, just to keep this, I want to say D in this case equal exactly the same thing, but for I. And then if D is less than the minimum distance, what should I do? I should make my minimum distance equal D. And I should also keep track. This is why here I need another, I would call it min index, like the index of the object with the minimum distance. And in this case, min index, let me initialize it to 0. And here, min index should be I, right? So I will keep looping, and every time if the distance is less than the minimum distance, I'm going to update the minimum distance and update my index as well, right? And simply, maybe at the end, I can print system.print line, all these things. So system.print line, and then min, okay, let's say object with min distance is number, and then plus min index. Good. So questions. Let me see if there are questions in this example. What is min index for, Karina? So the minimum index is the simply keeping track or what. So again, we have 10. Let me go back to the slides because I want to visualize this, right? So let me do this. So simply here, let's say those are 5 elements. I have 10 elements in my array, but let's say we have 5, right? So what I want at the end is to determine what was the object that had the minimum distance to the origin. So simply what I do is to say, go through all the elements one by one, calculate the distance, and then I want to keep track of the minimum distance itself, which is this one. This is going to be min D, for example. But also I want to know the object with the minimum distance. And this is why I am defining min index, right? That it tells me which object had the minimum distance to the origin, right? Okay, good. Okay, perfect. So this is, again, this is what we want to calculate, or what we are visualizing. But let me go back to the example and ask you one very simple question. If I just run this program as is, which object are you going to expect to have the minimum distance? 0, right? I just, what I have done is I made every object here equals to the index. So 0, 0, 1, 1, 2, 2, 3, 3. So simply is going to be the first one, right? So what I want to do different is I want to simply create some kind of randomization in order not to expect the result. So what you can do instead is to here, instead of initializing by the index, you can just say math.random, and let's multiply by a certain any factor. Let's say multiply by 10 or 20 or whatever, just to have some reasonable value, and then math.random, right? So math.random is a random function that gives you any random function, if I remember correctly, between 0 and 1, and then you multiply it by a factor. So simply, you know now your points are random. You no longer know the expected result, right? And then when you run this, you simply should get the first of all the minimum distance itself and the object, the index of the object with the minimum distance. Good. So are there any questions? Good. So that's okay. That's doing exactly what we have done. So let me show you in the lab the difference between these two types of methods. One method that is operating only on the instance members of the current object, this, and another method that needs really to operate in two different things, like distance too. It needs to take an object as an input and also operate on the current object as well, right? So let me open this. Where is my Eclipse? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, here. Then here, I hope you are able to see my Eclipse. Maybe in the matrix class, for example. Good. So one example of a method that operates only on the current elements or member or in instance variables of the current class is get element, for example, right? Like getters and setters simply are very simple example. Another one is matrix copy because it copies the current one, but it returns another matrix. While an example of a method that needs to operate on the current object as well as an object that is passed as an input parameter is the add2, right? So you can think of the add2 as the example of the distance2, right? And I always kind of guide you guys to do this, and I don't know why you usually don't do. You jump directly into the lab without looking into the lecture examples, right? So if I'm implementing the add2 method, the safest way and faster way for me is first to study the distance2 method in the lecture, make sure I understand it, I can write it myself, and then map my knowledge into implementing the add2 method. This would be a good way of studying and connecting both the lab and the lecture. What does add2 do? Simply you have two matrices, again your this, and another matrix which is M, you pass as an input parameter. And then you want to add these two matrices together if they match. So take every element by element, add them together, and then put the result back into the current matrix. Good. So that's an application of a method that operates on both the current object this and another object that you pass as an input parameter. Ishmam, can you use random to print within a random range of integers? Yes, Ishmam, you can do this. You can do multiple things by random, and there are many tricks of how to operate on random to operate within a certain range. But now this is not the time. This is not really what we are not after, right? What does throw do? Salah, this is a lab-related question. Simply in the lab, you are required to, for example, we said here in the add2 method, you want to add two matrices together, correct? What if the matrix passed input argument, its dimension don't match the dimensions of the current object? Then you cannot really add them, right? Because from the high school math rules for matrices, to add two matrices, their dimensions should match. The number of rows should equal to the number of rows, and number of columns should equal to the number of columns. Then that means now you need to check first these dimensions, and if they don't match, you need to return an exception with a message called invalid operation. The way you do this exception in Java is you throw an error. Here is an arithmetic exception. Go back to the video of the tutorial of last Friday, and I have shown an example of how to do this throw within the method, right? So it's simply returning an error message if something doesn't match. Okay, good. So is there any questions? So by now we are done. I guess this is the first time we are done early by a couple of minutes or so, but let me take a few questions, and then everyone else, you guys are free to leave if you don't have questions. Thanks everyone, and have a great day. Question AK, are we required to do our own error catching using throw and catch? Not throw and catch. You are only throwing the messages that you are required, that you are asked to throw, but don't. So catch is like try and catch, but you're not required to do try and catch. You are only required to throw errors in case of your checking is not correct, right? Again, Har Sahib, lab 2 marks, hopefully by end of today should be out. Okay. No other question, Salah. My Eclipse program that I use for C works and opens fine, but when I try to open the Java Eclipse, it says select workspace. That's fine. Select a workspace, Salah. No problem about it. Select any folder that can work as your workspace. This is simply a message that comes to you at the first time where Eclipse would require a default workspace or workspace. Why you think this is an error? It's not an error, right? Muaz, is the idea similar in C where you allocate memory for the array for pointers, then use Muaz? That's correct. As Yanha was saying, yeah, that's correct. So AK, yes, you can use the same Eclipse, but don't do this, right? Please follow the steps that I have done in the tutorial, and you are guided in the lab document to make sure you avoid problems, right? I mean, okay, you can use anything. Really, you can even don't use Eclipse at all. You use another IDE. But again, the general rule is to follow the directions and the environment of the one that you are recommended for the lab document and in the tutorials, to make sure we can help you when you face issues. Good. Okay, good. So thanks everyone. And is there a question?
Hello? Yeah, like I have there's a part I'm not kind of sure about the scope of the class. Like, are you saying that if two instance belong to the same class, you can actually access another instance private variable?
No, what I'm saying is another instance. I guess Jan, how you mean by an instance? Object, correct?
Yeah.
Yeah, correct. That's correct. This is what we have done in the distance2 method here.
Yeah,
correct. That's correct. If you go to the distance2 method, simply what we have done is we were
You
able
have
to access, let's see that, you were able to access that.x, where x is really
private.
a private of that object. But we are able to do this because distance2 is also a member of the point class, which is an object of the same point class, right?
So if they are belong to the same class, you can
That's
just
fine.
ignore
Correct.
that private sign.
Correct.
Okay.
Correct.
Just making sure.
Yeah. Correct. Yeah. Thanks. Okay. If there are no more questions, I would say thanks everyone and have a great day. And I will see you all tomorrow. Bye-bye.